What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we're looking at describing linear patterns algebraically. This is our Lesson 3 action task. Now there's a lot of writing on this one. Let's get right to it and see what it's asking us to do. It says, look at the pattern rules for patterns A and B. The rule for pattern A means that some number is multiplied by the term position n. The rule for pattern B means that the same number is added to the term position n. The value for the box must be a whole number, and it must be the same for both patterns. For example, pattern A could be 4n, right? You could have a 4 in here, 4 times n. And pattern B could be 4 plus n. Or pattern A could be 10 times n, and pattern B could be 10 plus n. Okay, so now we're playing two truths and a lie, using the following statements about the patterns. Which statement is not true, and we have to explain how we know. So number 1 says the first terms of the patterns cannot possibly be equal. I think the best way to do this, at least how I'm going to approach it, is to make a table of values. So my table of values might look something like this. So here we have our first two tables of value, and what I'm looking at is for pattern A here, it says something times n. So if the value of the box was 1, remember we have to have the same value in each one. So this one is 1 times n, and this table of values is 1 plus n. Now we can build our table of values. So 1 times n is just going to be 1, if n is 1, right? 1 times n. In this case, the n is 1. So 1 times 1 is 1. For the second term, I just put this n, right? Because all of these numbers represent n. So in this case, n is 2. So I go 1 times 2. And now I can put 2. And the next one is 3 times 1, which is 3. And that's 1 times 4, which is 4, and 5, and so on. For the second pattern, pattern B, I'm looking at 1 plus n. So here, my n in the first case is going to be 1. So I go 1 plus 1. And that is 2. And then I go 1 plus 2, which is 3. Then I'm going 1 plus 3. In this case, n is 3. So I've got 4. We can see the pattern emerging. It's 2, 3, 4, 5, 6. Now I might try a bigger number. Let's try 5. So now if the boxes here are going to be 5, then this is going to be pattern A now, and this is going to be pattern B, where our boxes are both 5. And remember, what we're trying to find is if the first terms of the patterns cannot possibly be equal. In the first case, these two first terms were not equal. One was worth 1 and one was worth 2. What's it going to be for the second one? Here we go 5 times n. In this case, in the first one, it's n. It's 1, so it's just going to be 5. And then it's going to be 5 times n, which is 2 now. So it's 5 times 2, which is 10. Then 5 times 3, oh, it's going up by 5s. Okay, then we go 5 plus n. So for the first one, n is 1. So we go 5 plus 1, which is 6. And now we go 5 plus n. In this case, it's 2. So 5 plus 2 is 7. 5 plus 3 is 8, 9, 10. So again, we look here at our first terms, and the first terms are not equal. So far it's true. Let's try one more set. Let's try 10. Now we have 10 times 1, right? n here is 1, so we go 10 times 1, and that's 10. 10 times 2, 20. Oh, we can see it's going up by 10s each time on this one. Now we've got 10 plus n. The value of n for the first one is 1, so we've got 11. Next we've got 10 plus 2, because the n in this second case is 2. So we change that n to a 2, and it's 12. And look at that, it's going up by 1 each time again. Again, what we're looking for in this first one is at this first term. These are not equal, these are not equal, and these are not equal. So it looks like this first question is true. Now I have shown my work, but it also says that we should explain how we know. So I would need to go and on the back of this page or on a separate piece of paper, write how I know the first terms of the patterns cannot possibly be equal. And I might say something like this. The first terms of the patterns can't be equal because the first term of pattern B is always one more than pattern A. Next it says, the fifth terms could be equal if one of the patterns begins with 8. Okay, well we've got to do another one. You might need another piece of paper. I'm just going to move this to the side and draw another table of values for 8. 8 times 1 is 8. 8 times n, which is 2, is 16. 8 times n, which is now 3, is 24. We're going up by 8s, it looks like. 32. 8 times 5, 40. Okay? So we've got the fifth term of the 8n, one in pattern A. Next we're doing 8 plus 1, so that would be 9 in the first term. It would be 10, 8 plus 2 is 10, 8 plus 3, 11, 12, 13. So if we look here at the fifth term in each, they are not the same. But that only answers our question halfway, because it says the fifth terms could be equal if one of the patterns begins with 8. So that's if pattern A begins with 8, but what if pattern B begins with 8? What would this box need to be if our first term was 8? Well, I know that I'm adding 1 to it, so this would have to be 7. So let's check what this would look like if we had a 7 in each of these boxes. What would our tables of value look like? Well, they might look like this, where 7 times n being 1 in the first case, would be 7. 7 times 2, 14. 7 times 3, 21. 7 times 4, 28. 7 times 5, we've got 35. Next, we can do the other one. 7 plus n, which is 1 in the first case, that makes it 8. 7 plus 2, 9. 7 plus 3, 10, 11, 12. Again, we can look down here at our fifth term and we can find they are not the same. So in both cases, if 8 is the value of the first term in pattern A, or if 8 is the value of the first term in pattern B, either way, the fifth terms are not equal. So I might write something like this. If the first term in pattern A is 8, the fifth term is 40, but the fifth term in pattern B is 13. If the first term in pattern B is 8, the fifth term is 12, but the fifth term in pattern A is 35. They are not the same. So we can safely say number 2 is false. Finally, it says one of the terms in pattern B could also be a term in pattern A. Let's have a look at all the tables of values that we've made already and see if we have the same number in any of the two tables. Well, I can see already, here's a 2 in the value here, and here's a 2 here, and a 3 and a 3, and a 4 and a 4. Okay. I can also see over here, there's a 10 here and a 10 here. Those are the last ones that I see, but we can definitely see that one of the terms in pattern A could also be a term in pattern B. So that is true. And I might explain it by saying something like this. If the box equals 1, pattern A is 1, 2, 3, 4, 5, and pattern B is 2, 3, 4, 5, 6. These two patterns share many of the same terms. That's it for today. Thanks for watching.